Have you ever noticed how reading a real, physical book just feels different than scrolling through something on a screen? Well, today we're going to dive into the science of what's actually happening inside your brain when you do. So let's get right into it. Reading on paper versus reading on a screen. You know that feeling, right? One feels focused, the other maybe a little more scattered. But is that just a feeling? Or does your brain actually notice a difference? You bet it does. And according to the research we're looking at, this isn't just about personal preference. We're talking about a deep, fundamental mismatch between a brain that has evolved over millions of years and a digital technology that's, only been around for a few decades. To really get to the bottom of this, we've got to start with the absolute basics, the physics of how we see the world. So, let's look at the paper brain versus the digital brain. It really all starts with light. When you read a book, you're seeing reflected light. Light from the sun or a lamp bounces off the page and into your eyes. That's how we've seen everything for our entire history. But screens, they use transmitted light. The light is beamed directly from the screen into your eyes. That's a totally new thing for our brains to deal with.
And what's so fascinating is that our brain actually has two completely different modes for processing these two types of light. It's like having two different ways of seeing.
Think of it this way. That natural reflected light from paper, it activates what's called the detective pathway in your brain. This mode is slow, it's precise, and it's all about digging into the details. But the transmitted light from screens, plus all the scrolling and movement, that activates the landscape pathway. This one's designed for speed, spotting motion, recognizing broad patterns. One is for deep analytical thought, the other is for shallow, quick glance recognition.
So does this difference actually show up inside our heads? Well, the cool thing is we can actually measure it. So let's take a peek inside the reading brain.
And the data is pretty stark. When you read on paper, brain scans show a big jump in high-frequency brainwaves. That's your brain in a state of deep focus. On a screen, you see more low-frequency waves, which are linked to a more distracted, wandering mind. And check out the eye movements. With paper, our eyes are predictive and autonomous. We're in the driver's seat, deciding where to go next. With a screen, our eyes are just reacting, trying to keep up with the scroll. And this quote just nails it. With paper, the reader is in control. With a screen, the reader is often just trying to keep up. It's all about control versus reaction. On paper, you are leading the dance. On a screen, you're often just trying not to trip over your own feet while the device leads. Okay, so this is where it gets really, really critical, because this difference isn't just a minor thing. It becomes hugely important during the brain's most formative years, when a child's brain is literally being built. Neuroscientists talk about something called the sensitive period. This is this incredibly important window, from birth to about age 10, where experiences don't just teach you things, they physically and permanently wire your brain. The kind of input a kid gets during this time builds the very foundation of how they'll think and learn for the rest of their life. Two key things are happening here. First, there's a process called myelination. Think of it like putting rubber insulation on an electrical wire. It makes the signals in the brain faster and stronger. But studies show that too much screen time can lead to weaker insulation in the brain's language centers. And second, you've got synaptic pruning. This is where the brain smartly gets rid of unused connections to become more efficient, kind of like trimming a bonsai tree to make it healthier. Deep reading on paper helps the brain figure out which connections to keep and strengthen, while the shallow processing from screens can mess up that whole process. And it goes beyond just reading. Look at the difference between handwriting and typing. When you write by hand, you activate this huge network across your brain. Sensory areas, motor areas, visual areas. It lights the brain up. Typing? It's a much simpler task that activates one small specific spot. The level of brain engagement isn't even in the same league. So, what in the world does all of this mean for us, for education, for this generation of digital natives? Well, it means we have a choice to make about the future. Now, the big takeaway here is not that tech is bad. That's too simple. The argument is that the problem is our over-reliance on a digital world that, from a biological standpoint, just isn't optimized for how our brains are actually built to learn deeply. So what does a more brain-aware approach look like? Well, the source suggests a pretty clear timeline. From birth to age 5, the focus should be almost entirely on paper, on handwriting, on building those core neural pathways. Then from age 6 to 10, you can start to bring in digital tools, but you keep deep reading on paper as the main event. And after age 10, you move to a smart, hybrid model where you use the right tool for the right job. And this all leaves us with one last big question to chew on. We call young people digital natives, and we assume they're just naturally wired for this world. But looking at the neurobiology, you have to ask, are their brains truly native to the digital world? Or are they still running on an analog blueprint that's millions of years old?